Hello everyone, good afternoon. Welcome to the last lecture of today. I had actually a great introduction by the previous lecturer. It was very dramatic, very pompous. And with this lecture, I would like to actually maybe start a discussion, and I will bring things closer to where we are now and do a little bit of self-reflection as a scientists, as a researchers, how we can actually contribute to the digital future of science. So my name is Matjaz. I'm leading the research and development at SciNote. SciNote is electronic laboratory notebook, a digital platform that can be used by researchers, scientists to document, to plan, document, and access their data. So there are some challenges that will be happening or are already happening as we speak, and we as a generation that's here on this planet we will be facing with. So one of them is global warming. We have a huge problem with antibiotics, so the resistance to antibiotics and the pipeline of development of new antibiotics in pharma is simply not catching up. And that's a fact. So population is growing, and so is the demand for food, actually. This is a chart that's displaying how the yield has been increasing for crops like wheat, soy, maize, and rice. So the green light is actually the line that shows how this yield has been increasing. This is the line that's an extrapolation to the future. And if you're going to be able to feed the people who are actually coming to the planet, this is not going to be enough. The yields will have to increase if we are not to overpopulate the entire planet with wheat, soy, maize or rice. So I believe that life science is one of the major fields that will actually have a lot to contribute to solve those challenges, and they will for sure happen in our lifetimes. And maybe to think a little bit about can science and research in general actually get there? Does the science that we do and how we do it today really matter? So I would like to point out 3 facts. So one of them is that scientific data output is actually doubled every 3 years. More than half of the studies that are published cannot be reproduced. Everyone who's been working in the lab as a researcher, I've been there, who wants to try and reproduce something that has been published, often it will fail. So obviously we are not doing something right, and this means that half of the money is spent and lost. So that's a big deal. And a lot of the data, 17% is quite a lot, is simply lost. So if we are actually the ones, the giants of the future, is the current way, the current practice that we have at science enough? I think we will have to change quite a lot of things, and one of those changes, so any tools, any search engine actually can only deal with digital data. If data is not digital, if it's not accessible, it doesn't exist. So going digital is actually one of the first steps that's required. So now a little bit of reasons why digital matters for people who are dealing with the financial part of science or research. We at SciNote did a little bit of study or research interviews with SciNote users, and we actually discovered that an average SciNote user, so SciNote being an ELN or a digital platform that they use on a daily basis or weekly basis, this can save up to 9 hours per week. So that's a whole extra day you get just by using a digital tool. Of course, this does come at an investment, so everyone needs to learn something new, and we've estimated that people need about 3 months to get proficient in sign-outs in an electronic or digital platform, and they have to spend about 40 hours in the course of those 3 months. But after that, the return on investment starts happening. When we converted that into money and applied this average salary of a US researcher, we saw that after 1.5 months after this scientist researcher becomes proficient in the tool, they actually break even with the investment, and then on they save up to $14,000 per year. That's simply just in time. Science is going through evolution. So I've summed up some of the trends. So there's more and more collaboration, not just interdisciplinary, so several different teams from different backgrounds collaborating together to produce something new. Also different geographies are collaborating, and that's basically calls for tools, platforms that can share and that can share data where people can access and exchange data. Internet of Things or Industry 4.0 is happening. This is, even on these trade shows, a lot of instrument manufacturers are saying our instruments are connected. We are storing the data that they can produce in a cloud, and this is a great opportunity for science to actually make use of that data from the instruments. New methods for data analysis are emerging, and a lot of them are being cloud-based. Some of the new technologies, so me coming from a molecular biology background, I'm aware of next generation sequencing. So that's a technology that uses extremely expensive infrastructure, instruments. They were actually forcing people who wanted to use those tools to actually outsource those bits of experiments to service providers that have that infrastructure. And this is a trend that's actually growing. So more and more experiments is being outsourced, which is perfectly fine. So people should actually focus on what they're actually good at. But this outsourcing actually means that the communication between external and internal collaborators will need to be improved, and digital is the only way. So there is some pressure on sign-outs that it becomes more transparent and more reproducible, and it is actually already becoming more interactive. And all those things were actually, in my opinion, reasons that these digital platforms, if you call them ELNs, electronic laboratory notebooks, are on the rise. So those are the tools, the primary tools that scientists use or can use to go into the digital age, so to go to the paperless. Well, maybe at some point we will get to Jarvis or maybe HAL 9000. So these perfect systems that answer every question, that have access to a lot of data and can do analysis in real time or near real time. I'm not sure if we're going to get there, when we're going to get there, but for sure is that again, digital is the common denominator for this. You might say, of course, there's tons of data already out there, but it's not standardized. Maybe the first step would be to go towards the standardization of that. I've been, I know for a few attempts of standardization, for example, in the DNA microarray data, in real-time PCR data, and whenever those attempts for standardization happen, someone discovers, something is missing, let's make a new overwhelming all-inclusive standard. And a year later on, something is changed, we have this discussion over and over again, but we have an additional standard. So this standardization may happen. I will also talk a little bit about it later on, but most probably it's not the first step that's required. And if we look at global standards, there is really very few truly global standards that actually exist. We have different electricity voltage on continents, for example, power outlets, different basic things that we use on the daily basis, but lack of standardization. Well, science is maybe a little bit on the contrary side with the standardization. So it's everything about new things, discovering new things, innovation processes, which is a bit of on the opposite from the standardization. But when we think about it, there is a big standard in science, and that's the scientific method. So this approach that's been around for a couple of 100 years results in a relatively standardized output that is in the form of introduction, material methods, results, discussion, literature. You can recognize this in graduation thesis, PhD thesis, original scientific journals, and things like that. So this is a kind of a standard. I believe that there is the need for digital tools, but there will most probably be a coexistence of several tools. There will probably not be a single tool that everyone will be using. There will be some sort of a smaller ecosystem. We are aware, for example, of some universities or research institutes that have been pushing their staff, their researchers, to use ELNs. But the adoption rate in those kind of circumstances is very low. People simply don't have the need to use a specific tool, or it's specific to a certain science. It has some features that's maybe good for molecular biology, but not so much for physics or mathematics. And the smarter institutions actually allow the coexistence of several of ELNs or digital platforms. So they see the goal of having things digital much more important than forcing a single solution, shoving it down the throats of every researcher. But what will happen, or what will have to happen, is the interoperability of those systems. If we have a look at, let's say, these 5 points, if they're representing data sources, maybe instruments or analytic tools that generate data. If you want to exchange data between all those points, there's lots of interaction, so it's quite a complex system. If we introduce a middleman, the number of integration is greatly reduced, and basically this integrator is the one who needs to integrate with a lot of data sources or sinks, and not each point. And the system is simplified. A little bit more real life example is the complexity increases, so more data points. And what's a practical solution is that we don't go integration from point to point, but we have several or more than one integrator. But the main point is that all those integrators need to have communication with each other. So this is the interoperability that I'm talking about. And maybe these points are ELNs. And this interoperability via middlemen is nothing new actually in the industry. So there are different technologies or platforms out there, for example, Zapier or IFTTT, that are these integrators. And if I want to integrate with a tool, I can do that via, for example, Zapier. And we believe that ELNs should become exactly that, middlemen for digital science. And to support this, ELNs must become what we call API-centered. And API, with this I mean application programming interface centered. So it's a kind of a standard way to exchange data between different softwares or different applications. They need to become interoperable. With this I mean that in addition to exchange data via the API, also some kind of a data format needs to exist that needs to be standardized to a certain level to exchange data via files. And ELN, since the very prominent goal of science is to publish. Basically, ELNs will need to support the scientific method and publishing of this scientific method. And last but not least, they have to bring an immediate value, a cookie for a researcher, for a scientist, that they will start using this platform. We at Synode are going into this direction. We are building, continuing to build an API-centered ELN. We are unifying the data model. We are supporting the integrations because that's the key, not just instruments, but other software platforms. We are integrating with IoT platforms of instrument manufacturers, which is the key to get as much data and metadata from the instruments because it's available. And we are actually encouraging and enabling community to develop more and more integrations. With all this API-centered approach, the security risks become more obvious. So if you have systems that do not communicate with each other, if they are standalone, you actually have a lot of security through obscurity. But now that the systems become more exposed or more interconnected, they become also more exposed. So that's a challenge that everyone will need to pay more attention and address. So to conclude, well, science needs to improve on availability of the data in a digital form, on transparency, and on the reproducibility of the data. And with this, this can be achieved only if science really truly becomes digital. And the last point is very important. Each individual needs to get involved. Every researcher has the responsibility that they make small step towards this, because they are responsible, not their bosses. I mean, also their bosses, supervisors, but each individual is really responsible to make this small step towards the future. So how to get involved? I would encourage anyone to start using any digital tool to manage your research data. You can start using Synode today. I also have some brochures here, so if you are interested, you can talk to me after the lecture. Get a free account on synode.net. Help us, and by us I mean the digital platform providers, to integrate with each other and with other softwares, sources of data, sinks of data, and promote the importance of making science digital as my last point. So thank you. It's been a very general lecture. It's been designed not to be too difficult for the afternoon, but I would gladly take any questions if you have them. Thank you.
Thank you for your talk. We touched on the lack of reproducibility.
Yeah.
Does that fit into the phenomenon of poetry journals that aggravates? There's so much pressure on researchers to publish, to boost their metrics. So how does that fit? I mean, that aggravates it, doesn't it?
The pressure. Oh yeah. Definitely. A lot of funding is actually based on impact factor points, metrics. So there is absolute no incentive for quality, just quantity basically. The quality of some major publishers is dropping also. I've been an editor for one scientific journal, and I know what kind of a pressure an editor has from the publisher and simply to manage the quantity of the manuscripts that you have to get. So there is pressure from all kinds of directions. What I see as a solution is that maybe the sources of grants, so the public bodies that give out grants, that they actually say, okay, it's the published results are not good enough. They have to be digitally available. They have to be, reproducible. And with this, I don't know, maybe there has to be some sort of a small revolution in the publishing world where, the researchers were actually not citing the research work, but actually doing it in the lab, that they gave some feedback. Okay, your protocol is not working. I've tried it 10 times, and the impact factor should drop. So, sorry?
Do you see a solution in open access journals?
Yes, possibly also in true peer-reviewed journals. So with the diminished role of formal editors. And other point is also publication of negative data. That would also help. If there is unwritten rule in science, if it works once, publish it. Don't repeat it. But if you were to publish all the data that's unpublished, it's also valuable data. Sometimes even more than the published one. Okay. Thank you.
Thank you. Can I take one?
Yes.